All right, we are in the last section of integrals. Not that we will not be touching these again. There are some other chapters later on that deal with integration, but this is the last section of this particular chapter, and then we'll move on to more complicated things. I'm sorry. So when you are finding definite integrals, those are the ones that have the number on top and bottom of those funky s's. So you're going to end up with just a number as your answer. So you're looking for something very specific. So first you find the antiderivative, and then you plug in the constants that are at the top and the bottom of the integral sign, and then you subtract the results. So we talked about this when we were talking about the fundamental theorem of calculus. Here's a quick example. If I have the integral from -1 to 2 of 3x squared plus 1, I'm going to first of all have to find the antiderivative of 3x squared plus 1, and that is x cubed plus x. Then what I have to do is plug in the 2 into here first, then plug in the -1 second, and subtract the results. And when I plug in 2, I get 10, and when I plug in -1, I get -2. And when I subtract those, I get 12. Okay, so let's look at what's going on here. Actually, let's look at a different example. I've got, I need to find the area under the curve. This is just another way of me asking the same question. I'm finding the area under the curve of y equals cosine 2x from x equals 0 to x equals pi over 4. Okay, same question. So that's what I'm looking for. The antiderivative of cosine 2x is going to be 1/2 times the sine of 2x, and I have to plug in pi over 4 first, then plug in 0. When I plug in pi over 4, I get 1/2, and when I plug in 0, I get 0. And when I subtract those, I get 1/2. So it's a fairly simple concept. We're just kind of doing one extra thing. We're plugging in values, subtracting the results, and that should give us a number answer, not a function answer that has a plus c. Interesting that the plus c never showed up here. If it did, it would show up here and here as a plus c at the end of each one of these sets of brackets, but every time it would subtract out. So the plus c when you're doing definite integrals is optional because it's just going to subtract out anyways every single time. So that is definite integrals. And if you have any questions, let me know. Otherwise, I will see you tomorrow.